Hi there, ladies and gentlemen, welcome back to the DutchRC channel for an interesting video, I think. I for one am quite interested to see the outcome of this video. At the moment I'm narrating this part of the video, I actually do not know the outcome, by the way. So like I said, I'm quite interested in the outcome of it. What we will be testing, or what I will be testing, is these three Lipos here. These are the new Hyperion G7 Lipos. Yes, so what is special about these Lipos, or what is supposed to be special about these Lipos? They are high voltage, which means the voltage per cell is a little higher than on regular Lipos. Now, you can use that extra voltage in two ways, really. One is to just have extra power, extra punch, more voltage. The other way is to increase the efficiency of your setup. Again, higher voltage. With that extra punch you could go to a different propeller. Say you are running a 5045 at this moment. You use this LiPo and then you go to a 5040, so a lower pitch, slightly lower pitch. But again, higher voltage, you end up that way with the same amount of power. And what's the use of that? Well, your amperage will be lower. Again, your power is a product of your voltage and your amperage. So again, with these Lipos you could end up with a lower amperage if you prop down. And lower amperage also means your electronics will stay cooler and live longer. And well, that's the two choices you have. Lower amperage or just more power, which I suspect is what most people will use these Lipos for. Now, these aren't the first high voltage Lipos, obviously. Lots of companies have high voltage Lipos. And I think the consensus on high voltage Lipos is that they do not last. After about 20-30 flights, they puff and they can't really be charged to their full potential anymore. And basically at that point you have a lesser LiPo than a normal LiPo. For the first 20-30 flights it does make sense, they do provide more power, but again they don't last. 20-30 flights is too few flights, I think, for a LiPo. And yeah, Lipos aren't cheap, so you want to get the most out of them. These, however, aren't only high voltage, but also graphene Lipos. Now, as you might know, the idea with graphene Lipos is that they should last longer, more cycles. So, do they? That's the question. So in this video I'll try and answer that question. Let's see, yeah, let me show you how I'm going to be testing these Lipos. Oh, by the way, I have, as you can see, three Lipos. One 1803S, one 1204S and a 1404S. They are all 45C constant rate and 90C burst. And yeah, that's it. And okay, let's see my test setup, so to speak. Okay, my white table is a little bit too small to fit everything in. Excuse me for that. And I'm sure you won't mind. Okay, let's see what we have here. I've got my Dremel small workbench over here, in which I have clamped down a big honking motor. This motor can quite easily run up to 80 amps, well 70-80 amps. At the front, probably not visible for you, I've got a Turnigy Plus 60 amp ESC. Now in our tests I will be running over 60 amps, so yeah, I hope I won't fry the ESC. There is a good amount of airflow going over the ESC, so I'm not too worried about that. On the left over here I've got a power meter. and obviously I need that to keep an eye on the voltage of the LiPo and on the amperage. I want to run these LiPos up to their full potential, which means around 65-ish amps. Yeah, we'll go over the figures in a minute. Let's see, I need a servo tester which will act as my throttle input. I've got a temperature gauge to keep an eye on the LiPo to see if that doesn't run up too warm, and the ESC. And let's see, oh yeah, I need a veneers caliper as well. I'll show you why in a second. So that is my setup. Oh, actually, let me connect things up so you can see it run. Okay, throttle at 0. I connect up a LiPo, one of the 4S LiPos. There, 4 beeps. And then I simply run up that servo tester. There you go. Like this, let me shut it down again so you can actually hear me. This way I run the throttle up until I reach the desired amperage at which I want to test the LiPo. And again, we'll go over the figures in a minute. And I keep an eye on the voltage because I want to end the run at a certain voltage. To be specific, I'll run them up to 3.5 volts per cell. And on a 4S that would mean 14 volts, if I'm not mistaken. Okay, I won't be running this motor at 80% in my with my studio lights here, because they'll be sucked into the propeller. And it's a scary proposition in the hole. Actually, let me show you how I'm going to be doing the tests. Yeah, if this propeller comes loose or if anything else goes wrong, I will be safe. Let me show that right now. Okay, here it is. Obviously I would have preferred a nice glass shielding safety panel thing, like the ones the Mythbuster used to use. I don't have one of those, so I've got my test rig up in the hallway over here. Then I close this door and oops, door stopper there, and then I can connect up the LiPo and run the motor up. Okay, so that way I can run the motor up without safety being a safety hazard for myself, so to speak. Like you saw, I run the motor up slowly to the desired amperage. I can see the amperage over here on my power meter. I can also see the total voltage of the LiPo. As mentioned before, I want to run the LiPo up to 3.5 volts per cell. And that's it basically. Yeah, that's my safety precaution. A bit of a barge job, but it'll get the job done. Okay, so that is how I'm going to be testing things. And what are the veneer calipers for? Well, I want to know if these LiPos will puff, right? So what I'll do now is I'll measure them before the test. Our 1803S, let's see. That one is 22.5 millimeters in thickness. The 1200 4S is 29 millimeters in thickness, and our 1400 4S is, again before the test, 33.5 millimeters in thickness. So that's our beforehand test. Okay, so you saw the test rig I've conjured up. Why have I done a test like this, or why am I going to be doing a test like this? Well, I want laboratory repeatable conditions. I could of course do all kinds of flights with these Lipos, but none of the flights will be the same, and if I ever do tests with other Lipos, I won't be able to replicate exact flights, right? So what I'll do is run these 3 Lipos, all of them, through 50 cycles. I'll charge them at 2 amps, nothing special, up to their full potential in voltage, and then I'll drain them with my test rig at the maximum constant amperage. So for instance, let's see, this one, the 1.2 amps per hour 4S 45C, you do 45 times 1.2, and then you have the amperage at which you could discharge this Lipo at a constant rate. So I'll do that for each of these 3 Lipos 50 times. Will take a while, of course. I won't have you sit through all those tests, of course. Actually, I'm gonna be doing those tests after I've shot this part of the video, and then I'll cut right to my findings, so to speak. Okay, so yeah, that's it. I'll be back in a few seconds for you, but probably a few weeks for me. Quite a bit of work this. 50 charging cycles per battery, 50 discharge cycles, 150 cycles times 2, kinda. Okay, be back in a few seconds. Alrighty, a few seconds later for you, but it's 2 weeks later for me, and I felt like sharing this with you. This is my checklist sheet thing, and let me show you what I noted in my tests. These are all the tests, of course. Actually, I'm done with the 4S's, and I'm now doing this 3S. Now, why am I doing this one last? Well, I have to use a different prop for this one. Lower voltage, so the prop spins a little slower, and this is an 1800 milliampere, so I have to run a higher amperage. Let me see, on this 1400 4S I needed to run it up to 63 amps, which is not a problem, I think, for the setup. And on this 1.2 4S I needed to run it up to 54 amps, which is not a problem at all. However, on this 1.8 amp hour 3S I needed to run it up to 81 amps. Yeah, and it's a 60 amp ESC. Oh well, yeah, so I'm not sure. I'm almost done with this series as well. I've got 2 more runs to go, but yeah. Okay, what else is interesting? Yeah, I start every run, of course, at 4.35 amps per cell, which means 18.92 volts in total for the 4S's and 13.55 volt for the 3S. And again, I'm running them to 3.5 volts per cell, which means 14 volt in total. My power meter only shows a total voltage, so I have to keep an eye on that number. And again, for the 4S is 14 volt and for the 3S 10.5 volts. The runs last around 4 to 5 minutes. I haven't really taken note of that, but it's around 4 to 5 minutes. I'm gonna do 2 more tests on this 3S. I hope my ESC and motor last, and then I'll come back to you. Okay, I am finally done, so it is time to get our results in. Let's see. As I mentioned, I did monitor the temperature of my lipos, and they obviously got warm. It peaked out to around 50 degrees centigrade. So warm to the touch, but not blisteringly hot. There was a good amount of airflow going over them, so that surely helped. But well, again, they didn't get blisteringly hot. So let's see. The first thing I want to know, have these lipos puffed at all? This 3S lipo, the 1800 milliampere, started out at 22.5 millimeters, and let's see what it measures in at right now. Okay, 22.5 millimeters. Okay, so no puffing there, that's a good result. Then the 1200 4S, let's have a looky. It started out at 29 millimeters. And it is now at, well, 29.5 millimeters. So it's still square, but okay, 0.5 millimeter thicker. Alright, and the last one, the 1400, started out at 33.5 millimeters. And let's see what it measures in at now. It's at 30, okay, 33. Okay, so this one has actually shrunk. Well, that might have just been a measuring mistake on my part on the original size. Okay, so that's looking very good, I think. They have not puffed, that's very nice. And the next thing we want to know is what their maximum voltage is like, so we'll check that out right now. The 3S LiPo. I hope the screen is visible. Let me zoom in on that. Well, you be the judge. Perfect score. 4.35 on all cells, very nice. Next one, the 1200 4S. Okay, slightly lower. The lowest cell is 4.33 and the highest is the 4.34. Okay, not bad. Not bad at all. The last one, the 1400 4S. What? Okay, more or less the same as the other 4S, as you can hopefully see. Oops, connector isn't in correctly. There. Again, they are all at 4.34. Okay. That is more than acceptable. Very, very nice. Cool stuff. Okay. And the last thing I want to check is the internal resistance of the LiPo. I'll just pick one, this 1400 4S, and let's have a look what our charger says. Okay, I'm using the Hyperion EOS 1000 watt charger here. Not a barge charger by any means, a high quality charger. And we're gonna test the or measure the internal resistance of our LiPo. Let's have a look. Battery resistance, weight, okay, I hope it's in view. The lowest is 19 micro ohm and the highest is 21 micro ohm. And if you don't know, I think those are more than reasonable numbers. One of the important things is that there isn't a lot of variation in the numbers, and they are, well, practically the same as a new LiPo, which is surprising, but very good, of course. Cool stuff, man. Okay, very nice. Wrapping things up, what does it all mean? Well, to me it means that I'm gonna get more of these LiPos. At this moment I only have 3 of them to test them, but I'm definitely going to order up more and make these my primary flight packs. I don't see any reason why not to. Yeah, sure, they are a bit more expensive than regular LiPos, but you do get more punch for your money. So, cool stuff. I have no idea what they will be like 150 flights. But, well, actually, maybe I'll come back to you with very long-term figures or outcomes or my impressions on these LiPos. For now, I think they are a viable option, for sure. I really like them. So, yeah, if you have questions, please let me know in the comment section below. Hope this video gave you some good information. And hope to see you back in another video. Bye bye.